Hello, greetings and welcome from AME Super English. We will continue with the symbols and the names of the elements as is given in the periodic table. I have already told you that to take a printout of this periodic table and keep it with you ready on your study table or in front of your study table so that by looking repeatedly you can remember passively. Okay. So I just recap what we have studied before. The first group, you should be able to recite this order like a nursery rhyme. What I suggest is you just leave hydrogen separately. Hydrogen is not exactly in the first group. It because it has both the properties of metals and non-metals, and therefore it is just placed separately just above the first group. Most of the characteristics or properties of hydrogen are similar with the first group elements. So the first group elements, lithium, sodium, potassium, rubidium, cesium, francium, you make it 333 so that it will be easy for to remember. Second one, beryllium, magnesium, calcium, strontium, barium, radium, beryllium, magnesium, calcium, strontium, barium, radium. Then go to the 13th, means third group, third main group. Otherwise, it's also called a 13th group in the modern periodic table. For that, you study boron, aluminum, gallium, indium, thallium. You only need the last one, or you only need two. Then comes the 14th group or the fourth group, carbon, silicon, germanium, tin, lead, carbon, silicon, germanium, tin, lead. Then comes the fifth group, starting with nitrogen, nitrogen, phosphorus, arsenic, antimony, bismuth, nitrogen, phosphorus, arsenic, antimony, bismuth. Sixth one, the first oxygen, the most important element in chemistry and in our life. 16th group or the main group, it is called sixth group. Oxygen, sulfur, selenium, tellurium, polonium. In that, only oxygen, sulfur, these two are only important for our chemistry studies, but you should know the symbols of that, the other elements also, because polonium will reappear again in physics. The last one is very important, like the first group, fluorine, chlorine, bromine, iodine, astatic. Fluorine, chlorine, bromine, iodine, astatic. You remember all these first four elements together because all of them are very, very important. Fluorine, chlorine, bromine, iodine, and last astatic. The last, you only need the name and the symbol only. The eighth group, they are called the inert group or they are called noble gases because they do not take part in any chemical reaction with any other elements. Helium, neon, argon, krypton, xenon, radon. Helium, neon, argon, krypton, xenon, radon. The last main groups are finished. This you have to study separately. And these groups are called families also. They have similar properties, and that is why we have to remember them in order of the group in the first place. And also, their valencies also will be common, except some variable valencies. Now we are going to the center part of the periodic table. Center part. Actually, we do not want to learn most of the elements in that central group. That group is called a transition group because their valency, that is the combining ratio, the combining capacity, their combining capacities are not constant. it will vary. There are different elements of different oxidation state or ratio state or combining capacity. Then you take the note of this one. First, starting with titanium. For titanium is a very much important element, metal. Then vanadium, chromium. Chromium is also very important in our daily life because whatever you see, shining plated things are alloys of chromium, manganese, iron, iron, cobalt, nickel. This I need you to correct some misconception because when you are studying in the school, the textbook and the teachers are only mentioning about iron as magnetic material, but that is not completely true. There are three elements, metals, having magnetic properties. So they are called magnetic elements. They are iron, cobalt, nickel, iron, cobalt, nickel, iron, cobalt, nickel, iron, cobalt, nickel. These, the presence of these elements are the real reason of the magnetic field of Earth. Then iron, cobalt, nickel, copper and zinc, they are very important, copper and zinc. Then go to the lower period, that is the row. Then let me check that what you need. You need only palladium, silver and cadmium. Palladium, silver and cadmium. Even though I have told you three, only silver is sufficient for you up to the 10th standard. Right. Then there is a element you should know, not for chemistry, for physics. Tungsten. Tungsten, the symbol is W. That is used to make resistances for electrical circuits. That is completely physics. When the electricity and magnetism, when we are going to learn electricity and magnetism, at that time we will discuss about that element. First main property is that it is a metal having very high resistance. When current is passing through that tungsten, it will produce a lot of heat energy because of the resistance, and two energies are produced, that is light energy and heat energy. In the past, it was used in normal bulbs, but nowadays that bulbs are not being used because when you buy that type of bulb, that bulbs are called incandescent lamps, means light is produced by heating of heating of a filament. So, but the problem with us, 80% of the heat energy, the electrical energy will be consumed for heat energy, which we do not have any use in the lighting purpose. Only 20% will be used for the light. So, we will be paying higher amount of electric charges for the company, and also we are not getting better result. That was replaced by CFL. In common, everybody says CFL, but most of them do not know what is CFL. CFL means compact fluorescent lamp. Compact fluorescent lamp. The next one is that you, in all your houses, you have a long cylinder like light, like a tube. We in normal English we call as tube light. In actual physics, it is called fluorescent lamp. Fluorescent lamp, FL. That is long. Then when the technology advanced, they made it into a very small compact model, like a bulb or like a small circling tubes in that, like zigzag circle. They are called CFL. The original name of CFL in physics is called compact fluorescent lab. Okay, that is W. That much you should know about W. Then comes iridium. Iridium is an element which has many physical properties similar to gold, and it is told that some of the traders are using this iridium to mix with the gold, which a customer cannot identify. So iridium is there. Then platinum. Platinum is a very good conductor and also is very expensive metal. Then comes Au, gold. Its Latin name is aurum. That is why the symbol is Au. Otherwise, it should be Go. In some of the elements, in the past, the scientists 200, 300 years before, they used some Latin names, and still some of the elements are bearing that Latin names. Then gold, and after that it is mercury, and below that, all the elements are radioactive, and the chemistry has nothing to do with that. It's completely exclusively for physics studies, and even that one is only for the very high level of studies. Okay, this is the first part, and if you need, you can just look at it again. Okay, right. Okay, then next step is what is an atom? Initially, the scientist John Dalton told that atom is indivisible. That is, atom cannot be divided. But later it was proved it is not exactly true. But his definition was almost correct, except for one reason. All the atoms contain three types of main subatomic particles. Sub means inside. There are many subatomic particles, but we only want to know the main three of them. They are called, I hope we can see. If you cannot see clearly, I will type it on the video. Yeah, yes. Proton. The symbol for proton is small p. Small p. Electron. Just opposite in charge. Sorry, I wrote electron. See how much we are affected by this democratic process. Electron. The symbol is small e, not capital E. Capital E stands for atom. This is also not E, small e. Then proton has positive charge and electron has negative charge. And there is a third one. It is called neutron, which symbol is small n, not capital N. Charge on the neutron is zero. It is neither positive nor negative. So, inside any atom, we can find the main components of the atoms are proton, electrons, and neutrons. Alright, okay. So even though at the time of the scientist, very respected, famous scientist who is considered as the father of chemistry, Mr. John Dalton, he has made almost everything correct, and whatever he has found out was correct. But only in science it is like that. Some scientist will invent something or discover something, and after that there will be some defects in that. We will rectify it. Only that. That doesn't mean John Dalton was not a bad scientist. Sorry, John Dalton was a bad scientist. No, it's not like that. Every time science is rectified, improved in that field. Okay. So, how is it arranged in an atom? All these three. The problem is that once again, proton is positively charged, electron is negatively charged. The problem is that you cannot keep them together. It is like keeping a fox and a chicken together. So what will happen? The fox will eat the chicken. That's the same way it will happen. Therefore, the nature has made some arrangements. That arrangements are like the solar system. Solar system. Solar system. So what is a solar system? We know our solar system. The center of our solar system is sun. Continuously the sun produces a lot of heat energy and light energy, and that is why we are surviving on different planets. Then there will be the first planet in the smaller orbit. Then there will be the second planet, third planet, fourth planet. What do you mean by that? Because every planet has its own path. That path will not coincide or intersect. They will not intersect. They are completely separately moving in different paths. And the first one is smaller, second one little larger. Then finally it will be the last, which is very far from the sun. Okay, similar to solar system. Here, instead of sun, there is a nucleus, and in the nucleus, what can you find? You can find the positively charged proton and zero charge neutron. They do not have a problem because neutron is neutral. So they will not attract each other with their electric charges. But if you put proton and electron closer, they will join together and the charge will be cancelled. In that way, the atom cannot survive. That is why it is placed in a different way. Okay, this is a nucleus. The first one is nucleus. Then, like the planets, there is a first orbit, second orbit, third orbit, like that it go fourth orbit, fifth orbit, like that. They are called energy levels also. And also, I have to remind you something. We are drawing this one in a plane only. Actually, it is like spheres, okay? It is like, if you can imagine, there is a central sphere made up of glass, and covering it, there is another sphere glass, another sphere glass, and the electron can move not only in this way, it can move in any direction because it is a sphere. Imagine an ant moving around an orange, an ant or two ants moving around an orange. Just think about that. The ant is not controlled by only moving in one direction. No, whatever he likes, whichever way he wants to go, that will go. It can go in some way like this way, or this way, or this way, because there is a lot of space around the orange for the ant. The electrons are also moving like an ant or ants moving around the surface of a sphere like an orange. One more point, I'll close this one, then we will continue the next class later. The first orbit can contain only first orbit 2 electrons. Second orbit can contain 8 electrons. Third orbit is also for up to our 10th study, we write 8 electrons again. Then if there is a fourth orbit, it will be 18 electrons, then 18, then 32, 32, but we do not need that up to the 10th standard. Now we are limiting our studies to 4, 8, 9 and 10 common. Because for the 10th students, you should know how to write the formula. The 8th students, you should know the symbols and names of the elements. For the 9th students, this is the fundamentals of chemistry starting. If you are seriously studying, following my class in this way, you can easily understand chemistry. When you come to the 10th standard, you can come, for sure you can get 95% plus or more in chemistry. Chemistry is rather easier than physics. Physics is very difficult in any classes. Okay, so I am winding up. One more point I have to tell you about the periodic table. I hope by the time you watch this video, you will have that periodic table with you. Hydrogen, English name; lithium, English name; sodium. If sodium symbol is Na, actually, you think there is a problem. It should be like SO or SD or SI like that. But it is only Na. Why? Because before I told you, centuries ago, many scientists have discovered these elements or studied about these elements, and they gave the Latin name for them. The Latin name for sodium is natrium. 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 That is why the sodium name started with Na. Then comes potassium. Potassium also it should be like PO or PT or something like that, but instead of it is K. Why? In the same way, the Greek name is Kalium. 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 That is why it's K. Then rubidium, cesium, francium is in our English names. There is no problem. In the second group, all are English names. There is no problem about that. In the third, 13th, gallium, indium, thallium, all English, and carbon, silicon, germanium. Fourth group. Come to the fourth group. Carbon, silicon, germanium. Okay, English names. But next is tin. Tin should be TN or TI. No. But it is SN. Why? The Latin name is stannum. 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 Very important. Next is lead. 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 That is the English name. Instead of the English name, it is PB then. PB. Now itself you remember. You know the people working with the electrical thing. We call them as electricians, and who are rectifying or fixing the pipes, water lines, and everything. We call them plumber. Remember that. Therefore, this name originated from the Latin name plumbum. Plumbium. Plumbum. That's why it is PB. Then go to the fifth group. Nitrogen, phosphorus, arsenic, antimony. Stipium, that is the name. Stipium. That is not English name. That is not Latin name. I think it is a German name or something. I'm sorry, I just missed out that. Okay, we'll correct it later. Then comes sixth group: oxygen, sulfur, selenium, tellurium, polonium. Leave it, no problem. Then comes seventh group, very important group, fluorine, chlorine, bromine, iodine, statin. Then comes the eighth group, helium, neon, argon, krypton, xenon, radon, no problem. But the main groups are finished. Then go to the center group, vanadium, chromium, manganese. Then comes iron, very important, iron. Instead of IR or IO or IN, they have written Fe here because the name is ferrum. Ferruium, ferrum. Cobalt, nickel, okay, copper. Copper has a little, you can say almost it is same, but original name is cuprum. That you have to study, cuprum. Because when we tell the names of compounds, we cannot say copper oxide. You can say copper oxide, but in some cases we have to use cuprum, cupric like that. Then zinc is same. Then silver, it is Ag. Argentum, remember Argentina. Remember Argentina team in the World Cup. Argentum. Okay. Next below that, iridium platinum. W. Wolfram, that's a German name. Wolfram. Wolfram. W, German name. Iridium platinum, gold. Aura. Aura. Aura means shining light. Like when you draw the pictures of gods or goddesses, they will put some light radiating outward from their faces. This is called aura. Because when they found these ancient people found it, no, it was shining with yellow color. So yellow light. That's why they gave the name auram for that. Then the last one is Hg, which is mercury, which is the only one liquid metal, and its name is hydrargyrum. 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 Okay, by this time you have to learn this one by group wise, and you should be able to recite it very quickly. Then only you can go very fast with the valency, writing compound's name and also. Okay, we will see in the next class. Thank you.